So I just wanted to make one more point about machine learning and in general about learning. So if we go back to just a sine wave like I had talked about before, if you wanted to recreate this curve, you can memorize every single point on the curve. All of these points. You could remember the entire thing. Or another thing that you could do is you could pick a point on the line, and from that point, work out how you get to the other point over time. And what this actually allows you to do is you could then rewrite an equation where you don't have to look at all of these points. What you simply do is you write an equation where you get y is equal to mx plus b, but m is just your rise over your run in your local vicinity. So you don't have to memorize everything, but you look at the data around you and you can find out what direction of the information that is nearby. So this way you're not memorizing the data, but you're looking at the overall data to help guide you get from one point to another. This means that in order to describe the entire curve, you just really need to know what the average distance is from this point to this point. We'll get more into that later, but the idea is frequency. And the idea is that basically, if you look at this way, just following a curve, it's just the idea of landmarks, right? You drive to a certain street, turn left, turn right. You don't have to know every single foot along that path. You could, and that's where you get the trade-off. So in one area, it's harder to memorize everything, but you kind of get the knowledge of everything, right? But here's the one thing is that if you spend all your time learning between this point and this point, what happens if we have this? There's a sharp increase, and then all of a sudden, it just drops down. Now, if you've never learned this, when you're asked to explain what happens here, you're going to assume this, if you're just going by total knowledge of the system. Whereas if you take this approach, the approach where we're looking at that point, and you come up here, and by the time you get here, you're going to see that, oh, okay, so the data all of a sudden drops down here. That means that your next point is going to force you in that direction. And so there might be some error. There's always going to be error, but there might be some error, but you will be able to more accurately describe the curve. So the overall trends. So in learning, we're basically trying to recreate the curve. And one way of doing that is we can memorize the entire thing, but memorization is really just kind of getting an alignment, so to speak. Whereas if we transform a little line segment along each one of these points, we can start looking at crazy complex signals like this and say, okay, well, this whole thing looks like a sine curve. I can call that one basis, and then maybe there's another sine curve on top of that, and I'll call that another basis, and that's a Fourier series or Fourier transform. And that is connected to the minimum amount of information you need to send the signal. Why? Because redundancy. You're looking at this, you're looking at how many things are different versus other points, and that's it. So this is, so in the idea of looking at the redundancy and everything, that's giving you actual intuition about the data. You sample the data in critical regions. You don't learn to memorize the whole thing, because if you learn to memorize the whole thing, there's going to be no way you can memorize the whole thing, because the universe is infinite, but it's also finite. You can't fit an infinite amount of information into a finite space. Arguments there, but yeah. So one way, it's really good if you have a lot of memory. That's like the internet, right? But if you want to simulate something, you kind of have to understand the dynamics of it. Literally, understanding, you're creating basis to form a set of knowledge, and a set of intuitions and actions and transforms from one state to another. Basis functions.